transformations. There's not much to teach here. Just the investigation from yesterday. And if you didn't do the investigation, I'm going to give you hints in the investigation right here, what you have to accomplish, because I'm going to give away some stuff. If you did the investigation, you might want to listen carefully, because you might get your investigation out while I'm teaching and go, I'm going to fix that. He said that in the lesson, okay? Y equals 2 sine x plus 3. Let's start with the part we know. My apologies, I'm still working on the ins and outs of using this active board. Can we, right off the bat, pick off the 2 transformations? There's only 2 there. This part hasn't changed. That's why I beat transformations up so bad in that first chapter, so that when we came to this, it's like, oh, no big deal. What are the 2 transformations you see there? Vertical stretch. Stretch times 2, which if you did the investigation, you say, like, I already know what to do. I know exactly what to do. And then vertical translation up 3. Now, if you're looking at that up 3 and going, how am I supposed to know the difference between vertical and horizontal here? I'm a little messed up by sine and cosine. That's fine. As the lesson goes on, you'll see how that plays out. So don't worry too much about that. Was that me, Esther Rose? I'm sorry.
It doesn't factor unless you want me to use imaginary numbers. I've tried fixing this and tried factors. It just does not go.
Quadratic formula? Oh, then do what you have with what you have. Yeah? Okay. Like, show what you're saying. Okay, here's what you should have got from yesterday's transformation, or sorry, yesterday's investigation. I'm going to move way over here because I know it's all vertical, so I'm moving over here. Here's what you should have got, and you're going to need to memorize by the time test time comes. Memorize. You could build this table of values with your calculator very, very quickly. So I don't know if you need to memorize it. Homework and stuff's going to go quicker if you memorize it, though. Does it seem like I have it memorized? Yeah, I'm not looking. You shouldn't be impressed by that. You're like, oh, you've been standing here for 25 years. Of course you have it memorized. But you see how things go faster if you do have it memorized. I'm not punching in my calculator, making sure I'm in degree mode. I'm not playing around. I know what's going on here. So you have that memorized. That's good. And then there's only 2 things to do. Vertical stretch times 2. I just multiply all those values by 2. Yeah, 2 times 0 is not 2. 0, 2, 0, negative 2, 0. Now, listen, I know I've left out something. I know. If you're like, well, how do I know? That's all you need from the table of values yesterday? I say yes. If you did the investigation and you know the shape of sine, if you know basically what this shape's going to look like. It's not a parabola. It's not an exponential. In your brain, when I say sine, hopefully you're like, oh yeah, now I've done the investigation. I know basically what these things look like. That's all the points I need. And then what, up 3? So that's 3, 5, 3, 1, 3. Don't let me away with it. I might have conquered this lesson already. It's possible I can now send you home. You're like, oh, I know what to do now. So don't let me away with any of it. If you're not sure on the initial table of values, if you're not sure on what I did in those 2 columns, tell me now. I'd like to talk about it more because I'm about to wrap this lesson up. Well, I'm going to do a bunch of examples, all the different things that could happen to you. But the main parts are already over. Tell me questions. Okay. Now I'm ready to graph. There's my x values, there's my y values. The difference here between those other ones is the scale along the horizontal axis is going to be giant. Instead of being 0, 1, 2, 3, 4, I got to go 90, 180, 270, 360. How many squares have I been given here? you're not going to have this problem. When you on your graph paper, you're like, I don't care what I go up by, but I got to be a little more careful because I only got a certain number of squares. So 3, 6, 9, 12, 15, 18. I got to be careful. I can't count on the screen. Okay, so I'm going to go like this. I'm going to go 90. There we go. I'm going to go like 90, and then 3 more squares, 180. 3 more squares, 270. 3 more squares, 360. That's what I'm going to choose to do, okay? I could have made other choices. Oh, wow. Did you see all those colors come up? I'm excited. I can have other colors. Did I get red here? No, I didn't. I'm going to cheat and use the mouse. I'm not sure why that's being awkward, but I'll cheat and use the mouse to get that red in there. Oh, maybe it thinks I'm using the second pen. Oh, maybe that's what's going on. Thanks, Nick. I'll take a look at that one.
No, I figured it out.
Oh, it worked out. Okay, scared me, buddy. X value 0, Y value 3. X value 90, Y value 5. X value 180, Y value 3. X value 270, Y value 1. Oh my goodness, look at this. Look at, somehow I can do this. It's wild. Lots of learning to do. That's the part I can't figure out yet. Is this a better board or a worse board? I think it's better overall, but you're just seeing my, you know, the other one, when you saw me work on it, I'd been working with that thing for 15 years. I knew all the little ins and outs. And even when it was being troublesome and difficult, I knew what to do. I'm often hampered by my own inabilities. Okay, where was I? 270, 1. I know what's happening. You can't hold like that. Thank you. $271 and 363 again. Okay. Is that enough? It is if you know the shape of sine. If you know basically what we're talking about here, that we're basically talking about little waves. That's what to remember. If quadratics were parabolas and linear was lines, and exponential was this curve that went off like this, what you should think when you see sine and cosine is this, and very repetitive. So that many points, 5 points is enough to go, oh, I got it. There's one cycle. And a lot of the homework says graph one cycle. You could graph more. So here's the part where you might go back to your assignment. This graph goes on forever in the same pattern. It keeps doing the same thing. It goes negative. It goes positive. It goes forever in both directions if you want it to. Yes? So I'm going to put arrows on the ends. And that's my little hint on the assignment is to go, yes, and this thing keeps going. And then another question, I might do 2 cycles to get you used to that or whatever. But that's the basic idea there. Okay, any questions about that? Okay, somebody else looks at it and goes, wait a minute. Isn't there slightly faster way to handle all this? And I'll switch to my other flip chart. That's the exact same thing. And you don't have to switch over. You don't have to do anything. Just look at this and see what you think. Somebody else goes, couldn't I just look at this and go, hey, the amplitude is now 2. See, when we did an investigation, the amplitude was 1. But this has been vertically stretched now, so its amplitude is now 2. You could see right through everything that's happening here. And you could also say, oh, the period is 360 degrees. You found out yesterday that the period of sine and cos, they repeat every 360. After 360, it just does the same thing over and over again. Can't I just use that and quickly draw a graph? And boy, I need the colors here now. I need this to go orange on me. I need orange. Come on, give me orange. Oh, it went orange, okay? I need orange. And all I'm going to do on here is I'm going to go, okay, I'm going to use the same scale as the last one. I'm just going to go, okay, sine goes, oh, it's going to go crazy on me here. I'm going to do it with my mouse. Sine goes up 2, back to 0. Oops. I said up 2 and I went up 3. Up 2. Up 2. Down to 0. Down 2. Up to 0. Oh, almost did it. Mouse writing is extremely difficult. Yeah, couldn't I just draw that like that and just go, oh, amplitude, double, still same period 360, and I say, yes, almost. What's wrong with this one? It's almost right. The vertical translation. So some people do this in 2 steps. They just go, okay, I'll get the right amplitude and period. I'll get that right off the bat, and then I'll do vertical translation up 3, and I'll just take that whole graph and move it up 3. Okay? I'm not trying to do a sales pitch. If you think I'm on either side of this, I am not. I like the table of values method, but you could totally look at this and go, get the right amplitude and period, and then just move it around from there. Now, I did it in orange. If you do this method, you should draw this one really lightly. Orange will represent really lightly. That's me drawing really light, because hopefully you can see the orange just barely on my screen. And then if I want, then you go dark on the other one, you move it all up 3. And I'm not doing great on the scale, okay? And I'll do that in a minute. Then you just move it up 3 and you get the graph that you had before. Was there a question there? Or I answered the question as I kept going there? I've got some details, but that's the basics. The work we did on transformations earlier in the course pays off here. You know, just give me the new base table and I can do the rest. Okay? Let's try another one. But I'm going to try it with the table, because that's the one I think when people have trouble with these, they prefer the table. When you're starting to get it, you might prefer the second method. Yeah? Boy, that sounds like I'm making a sales pitch for the second method, doesn't it? I'm not. I'm trying really hard, because I'm a physics dude at heart. Really, a lot of my background is physics, so I'll lean towards the physics stuff. So if I'm not careful, I like this here. I'm going to do it like here. So, same as before. Name the transformations. 1, 2, I see. One of the problems I'm having is I got to get straight up here. Harry, can I move you back just a little bit? Because that pen wants to be straight up, and if I angle it all, it has trouble. What are the 2 transformations that you see here? Vertical compression times 0.5 or 1/2. Oh, things are going better now that I'm a little more lined up. Oh, don't go off that way. Did I learn that yesterday? It does funny stuff if I don't go off the screen this way. Good. Something else. Plus 90 degrees.
Horizontal.
Yeah, horizontal translation. And if you had trouble, I saw some frowns. But now that you see where a horizontal translation will be, maybe you're a little more satisfied. You're like, oh, I'll be able to tell the horizontal. It's going to have brackets around it. That's not going to be a big problem at all. Horizontal translation, okay, plus 90, left 90. And if you drifted off to sleep because you're like, I was really good at transformation before, I did my investigation last night, I know exactly what's happening here, hold on for 1 second. Detail here about all this. You build your base table for y equals cos theta. I know it. I'd like you to know it. That's why I don't want the investigation handed in yet. I want you to have that thing around so you know cos very well. But if you were absolutely stuck, you could rebuild it. You type in 0, and you put that in your calculator, and you get 1. You type in 90, and you get 0. One of the points of the investigation, or one of the big ideas of the investigation was that those are the key points. Those ones in between gave you in between decimal points. Yes, I tortured you with all those decimals, but in the end, all you saw was these curvy waves, and these are the important points. 180, -1, 270, back to 0, and 360 back to 1. And then the whole process repeats again and again. It's periodic after that. We have two things to do. We've got a vertical compression times 0.5. So this becomes 0.5, 0, -0.5, 0, and 0.5. If you're into method 2, you're like, oh, I could draw this without all this. 0.5, I'm just going up and down from 0.5 to -0.5. And then left 90 is over here. And this is the part, again, if you've fallen asleep on me, you might want to check this out, because look what happens. -90, 0, 90, 180, 270. And there's lots of things you could do here. I included negatives, because you could just go into the negatives. That works just fine. Moving forward, especially if you're taking advanced functions, we'll really want these graphs to start at 0, and we'll talk a lot about what happens at 0 and the one cycle after 0. So I'm going to do both at the same time. You guys can do this totally. Let me put the scale on here. I'm going to use this as -90, 90, 3 more squares, 180, 3 more squares, 270, and 3 more squares, 360. Okay? So I'm going to write something that's okay for us now that we may want to improve on later, which is just to graph those points. And I'm going to switch over to red. Am I? I was getting good at this yesterday. Oh, hey, did you see that? I'm improving already. -90. Okay, well, all right, hang on. I'm going to go back. When it's 0.5, I know the temptation is to just go half, but I think the thing to do here is change the scale to 1 and -1 like that, and give yourself some room to operate, as opposed to going 0.5 and putting it down between one of those squares. You get lots of squares there. Label them like that. So -90 was 1. 0 was 0. That's incorrect, isn't it? I said it and then didn't do it. There we go. One too many undos there. -90 was 0.5. 0 was 0, yes. 90 was -0.5. 180 was 0. 270 was back to 0.5. And then you connect up the dots, doing the nice wavy look that sine and cosine beautifully have. One cycle of cosine looks weird. It doesn't look like the nice wave. So I'm going to continue on, but I don't know. Can someone tell me what the next point is? Without doing the next thing on the table. I'll do the table values. But where is this going to go? What would the next point be as this thing keeps going? Back to 0, 90 degrees later. Is it always 90 degrees? No, no, that's one of the details I got to show you. But on the regular ones, if it hasn't been horizontally compressed, it goes back to 0 again. That's what we'll do a lot of in advanced functions, is we'll finish the cycle that starts at 0. But you can use the negative to do it. And I tell the advanced functions people, use the negative to do it if you want. That's no problem. You just have to continue the pattern. And let me put arrows on the end to really, and I'm going to really give it away here for you. The domain of all these sine and cosines is x elementary reals. I know I just got you to graph 0 to 360 on the investigation, but they go on forever. The other way to do that And I'm not doing a sales pitch for it. It may seem like it because I'm going back and forth and I'm doing it second. It may seem like I'm going, wow, that's fine, but here, do it the good way. No, no, I'm just showing you an alternate way that some people's brains really work, is that if I go to the other flip chart, oh, don't do it with this hand. I gotta do that with the left hand. There. And then use this hand like that. Okay. Is that right off the bat, you can go, okay, I can see right away what the amplitude's gonna be. It's going to be 0.5. I can see that as the vertical stretch instead of going 1 to -1, because sine and cos have a nice amplitude, 1. So now it's 0.5 to -5, and the period's 360. You're like, is it always going to be 360? No. Brace yourself. Don't fall asleep, because it doesn't always have to be 360. And then you could draw one with that amplitude in that period, ready to rock and roll. So you go, okay, same as I did over there, 1 to -1. 90, 180. I'm going to do better on the scale than I did in the last one. And all I do, cosine starts at 0. You're like, wait, I didn't know cosine started at 0. I'm like, I know. I got to talk about that too. What you should memorize about sine and cos. More to come on what you should memorize about sine and cos. There's one cycle, not perfectly neatly. But it's not done. That's not correct. That has the right amplitude and period. Then you'd have to take another step and take that whole thing and move it left 90 degrees. But some people like doing this. They're like, okay, no problem. I've got that graph, which I was supposed to do in orange, but I didn't. So I'll do my final graph in green. And I just move everything left 90. So this is 90 over. This one's 90 over. This one's 90 over. This one's 90 over. This one's 90 over. And do you see I'm getting the same graph I got on the other one? I know they're overlapped, but if you draw the first one really lightly, it comes out really nicely. Okay. Just so I know who I'm teaching. At this point, if you had to do one, would you do it method 1 or method 2? How many people are method 1 people? How many people might be method 2 people? Yeah, that's exactly how it goes. That's exactly how it goes in advanced functions too. So in advanced functions, you can do it either way. It doesn't matter. What happens, by the way, is you get so good at them that you don't use either of these methods. You just get very fast at them as you get used to these functions. But that's a long way off. We don't have to do that right now. Back to the first one. Oh, don't do that. Use your left hand. Is this your example 3? Okay. And if you've drifted away on me, this one's got a different period. This is the one that might mess you up a little bit, if something's going to mess you up, okay? Starts the same way. Identify the transformations. Vertical stretch. Times 3, hopefully that's getting to be old news. Right 45 degrees. Hopefully that's also old news. You're like, yep, got that. How about the 2 inside, though? Horizontal compression. Don't want to use up all my space here, so I'll just slide it in there, right? Horizontal compression factor 1/2. Now, method 1 people, that won't cause you much trouble. It really won't bother you that much. You'll build your table of values for sine this time. I got to do 2 horizontals and 1 vertical, so I'll just put it over here a little bit, just in the interest of space. There's y equals sine x. And here's the memorization part of sine. The part you really want to memorize about sine is, sine starts at 0, but on its way up. That's what you really want to get cold. That way you can build these table values quickly. Sine starts at 0, but on the way up. And I'm telling you, once you get used to these, that's all you got to remember about sine. Start at 0, on the way up. So it goes up from there. Then you can do all this stuff. Vertical stretch times 3. Just multiply all these by 3. Easy enough. And I got to do 2 horizontal things. Which one do I do first? Do I multiply first or do I add first? Multiply. That's just BEDMAS. That's as simple as that is you got to do multiplying first. So first I'm going to multiply by 1/2. I know what's happening. Oh, I escaped that time, didn't I? Lots going on up here. Times by 1/2. You method 2 people are getting a little worried. You're like, huh? Don't worry, I got something to say in just a second that's going to help. And then write 45. So I'm adding 45 to all these. This is 45, 90, 135, 180, 225. Both groups of people, I say to you, you don't want to decide in your scale to the end. Not until you see these points. You know, well, what scale should I use? Should I go up by 1s? No. 2s? No. 30s? No. 15s? Maybe. 45s? Could be. Let's see if 45 works out nice. 45. Ooh. I need something else here. I need something to be able to touch this screen with that doesn't activate the touch screen so I can point. 45. Does that even work? It does. Jeez Louise. That's trouble. 45, 90, 135, 180, 225. Yeah, that's going to work. So I'm going to go 45 every 3 squares. It's not the only choice available. It's just what I happen to choose here. I'm going to choose 45, 90, 135, 180, 225. I'm just going up by 45s, 270. Because that's what I saw my x values do. They went up by 45s. Won't that make my life easy to go up by 45s? And then amplitude 3, so I'm just going up by 1s along there, so I don't have to do anything there. So now I'm ready, and I can go in red for my points here. You might have selected purple, but I'm going to go with it. 45, 0. Good. 93. 135, 0. 180, -3. 225, 0. Geez, I know the pattern. You see me not looking anymore? Once I get a couple of points on there, I already know what's happening. Missed. Zactaboard has the same problem with the other one. Sometimes I'm in the shadow and I can't see what I'm doing. Well, sorry, those are all the points I had. I got carried away and did the next point. How did I know? I just knew every point was moving over 45 and then up or down 3. And I'll accept that in this course. I'll be like, yep, that's fine. For advanced functions people, you should really finish this thing off to 0. We really want to get the full cycle back to 0. So then I go, okay, well then the next point this way would be 45 over and down 3. That would be the next one. Little arrows in the end to indicate, yes, this thing would continue on forever in both directions. I'm not doing all that. I'm only doing one cycle. Now, I'm going to do it the other way. And then I'm going to pause because you may have noticed I'm not actually answering the questions, by the way. The question said to do something different. But I'm now set up to answer the questions. I'll do that in just a second. Here's the other way to do that. Method 2 people, you'll go, okay, amplitude equals 3. And then you'll have to think this much. What's the period of sine and cosine normally? How long does it take to repeat sine and cosine? And I'll give you a hint here. This will be your visual hint come test time when you're trying to remember the period of sine and cosine. Are you ready? You got to watch me. Here's my hint on the period of sine and cosine. For those on the video, I'm just turning around once. How many degrees before I'm back where I started? 360. So for most situations, the period is going to be 360. But the period here isn't 360. What's happened to the period here? It's been horizontally compressed by factor 2. So that's what method 2 people will have to watch out for, is use this. And if you take physics, you'll actually have a formula for this. You actually have a formula called period equals 360 over k. And I'll put that over here in a heart for you method 2 people, because you're going to like, I love that. Just divide it by whatever numbers in the brackets. But let's not get carried away with this. I'm not trying to upset you or anything. And then afterwards, I'm going to have to move this thing right 45 degrees. And this is the big challenge of method 2, is before you start, go, what scale should I use? And the right 45 is the hint that you should go by 45s. 45, 90, 135, 180. And now, as promised, back to orange. Orange to me is supposed to represent you drawing very lightly. Just so you can just barely see it. A sine graph that's amplitude 3 but period 180. So that means here, 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 here. Amplitude 3, period 180. What's wrong with it, method 2 people? You still got to do right 45. So then you get your darker pencil out, or you just write. And you take all those points and you move them right 45 degrees. Do you have any questions about? Oh, arrows on the ends. There's one cycle. Any questions about the method? I forget how many I have to do. But let's just rewind. Let's go back to method 1 and rewind to the start, because I believe I have not answered the questions. For each of the following, state the amplitude. Once you're done graphing, those jobs are easy. Amplitude. You look at the graph and you go, oh, it's 2. Period. You look at your graph and you go, oh, it's 360. Domain. X element of reals. Range. Well, this is the hard part. What's the range? Well, if you got the graph, it's no problem. If you don't have the graph, good luck. Yeah, so when people text me and say, how do I get the range? I said, did you graph it? And they're like, oh, no, I didn't. So then once you graph it, you have this. It's from y element of reals such that 1 is less than or equal to y is less than or equal to 5. Is it possible to do the range without graphing? When you know them really well, maybe. You got to be really good at them. Shh. And I sketch one cycle. Now, it mentions phase shift. And the only reason I bring up phase shift is for those of you who might take physics or chemistry later. Phase shift is just the left-right. That's just another way for saying left-right. So there's none here. And I'll do that phase shift in the other ones in just a minute. Any questions about actually answering the question? You get that all off the graph. Can you get it right from the equation? Yes. Once you're good at them, you might be able to do these right from the equation. It's possible. More time there? My brain tells me I got 6 to do. That's why I stopped after 3. Am I right about that? I gave you 6 of these? Yeah. Okay. So I'm about half done. This one, amplitude. Well, who wants a shot at it? What's the amplitude? Yeah, the whole height is 1, so the amplitude is 0.5. Hopefully, whether you're method 1 or method 2, you're like, the amplitude is just this number out front. That's nice. That's what's nice about sine and cos graphs. The amplitude is laying right out front. It tells you. Period. I can see on the graph, this thing takes 360 to do a full lap. But now there is a phase shift. Have you ever heard the term out of phase? We're very close to understanding why things are called out of phase or phase in and out. When things are out of phase, they've got some kind of phase shift that's gone on here, and that's the left 90. So that's just another way of saying the left right. Domain, X element of reals. And the range, Y element of reals. Now look, watch me. I looked up, right? I'm not asking you to know the range without looking at the graph. Get that question all the time. Mr. Todd, do I have to graph it to get the range? Absolutely. If you're asking that question, absolutely. Is it possible to become so good at these that you can just look at it and know what the range is going to be? Yeah, but that's not what we're trying to accomplish. We're going graph it, and then you can get this information. More time there? I see some people with their investigation out now, too, going, oh, yeah. This helps me to answer these questions on the investigation. This one, amplitude, 3. Yes. A for amplitude, absolutely. Great short form. Everybody uses that short form. So we'll switch over right now. P for period, yes. Physics people, you'll use T for some reason. But P for period is fine for us right now. Phase shift, 45 degrees right. Domain, let's be a little careful. Does every sine and cosine have domain X element of reals? No. You could talk about the domain of one cycle or the domain of something that only goes around 3 times. Yes, you can do those things. But when we're doing graphs like this, the domain is always X element of reals. Range, Y element of reals. Look, I'm going to have to look up. I don't know what the range is. -3 to 3. I just look up at the graph and see what I got. Any questions there? I don't think I teach anything new the rest of the way. I just do other combinations, just play around and get to know the combination. So I'm not saying go to sleep. I'm just saying you shouldn't expect another big shoe to drop. Some math lessons are like that, right? Right when it seems like you just get it, and then I do something crazy at the end. Nothing crazy coming the rest of the way, just more of the same. And the homework's more of the same, lots of these. Practice enough that you're like, yep, I can do this every single time. Especially advanced functions people, because we're going to do it slightly differently in advanced functions. You've got to be ready. This has got to be pretty straightforward for you. More time there? Okay, -4 cosine x minus 90. 3 transformations here. Vertical reflection. Vertical stretch times 4. And then another one of these right 90 degrees things. So 2 verticals and a horizontal, so I'll do the table just slightly this way. Who's at the point where they feel like they're sort of starting to memorize these? Maybe it's way too early. Maybe I'm crazy to think that already you'd already know what cosine starts at. Does anyone know what cosine starts at? I'm seeing 0s and 1s out there. It's perfect. That's exactly where we should be right now. Where you're like, is it 0? Is it 1? Yeah. I know they're both sort of the same, but they're just off a little bit. That's where you want to get to. You want to get to, it's like, okay, cos starts at 1. On its way down. Look how fast that can go. So I'm not asking you to memorize it because I'm a nerd, because I'm your math teacher. I'm asking you to memorize it because things are going to go way faster for you. If you just get that thing memorized, wham, things are going to go very, very quickly when you do that. Then you can do your vertical stretch times 4. Whoa, that was fun. I have no idea what just happened there. This must be what it's like when people first get an iPad, right? Like, why did all the apps just minimize? Because you did a swipe. I don't know. I just did some swipe there. I don't know what happened. Vertical reflection. You can do the stretches or reflections in either order. They're both multiplying, so you can do them in either order, and then write 90. Since the period hasn't been changed, 90s is a great scale. If nothing's happened to the period, usually 90s works really well. So that's what I'm going to do here, 90, 180, 270, 360, 450. And I'll go right with my final color here, because in this particular case, I'm not trying to do method 2. So 90, negative 4, 180, 0, 274, 360, 0, and 450 back to negative 4 again. Okay, can anyone just look at that then and tell me, especially you people who want to take advanced functions, we're going to try and get all of them. We're not just going to have random cycles out there. We want the cycle that starts at 0. We've got the information we need to do that. Where is this function going to be at x equals 0? What y value will it have?
0.
0. Yeah, you can just look backwards and you can just count squares. It's just a pattern, right? 3 squares over, 4 squares up. 3 squares over, 4 squares up. So that's not as difficult as it seems. So I encourage you, even grade 11s, who maybe aren't thinking of taking advanced functions, to finish off that cycle back to 0. That's where you really want things to be. Now I've got some questions to answer, do I? I forget what the questions were. Amplitude, 4. Period, 360. Nothing's happened to the period here. Phase shift, right 90. So that phase shift is just another word for the horizontal translation. Big time physics word. What else do they want? Domain and range? Domain, x element of reals. So I'll put little arrows on there to remind myself the domain of this thing. Range, y element of reals. Look up at your graph. Negative 4, less than or equal to y, less than or equal to 4. I did that one only method 1. My intention is to do one of the last two with only method 2. Trying to jolt everybody a little bit to go, just don't fall in love with the one you fell in love with in the first 15 minutes of the lesson. Check out the other one, see what you think, okay? I don't know if I should do the next one. I'll look at it. I'll look and see what E is. Again, I don't want you to also think that every sine and cosine has domain x element of reals. Yes, and they do, unless something else is said. You could say, oh, a Ferris wheel goes around twice, and that means it does have a domain restriction because it only goes around twice. So there could be restrictions there. Any questions there? This sometimes goes very well for grade 11 students, by the way. All your experience in transformation, you're like, okay, This is no problem. This is the same as the other stuff. I don't know why you're even teaching so long. With yesterday's lesson and what I know about transformations, I'm good. Maybe. This is a good one to do with method 2. I'm going to take a shot only with method 2. And if you don't like it, as I'm doing it, you can totally go, nope, I'm going to do it with method 1 and make sure I get the same answer. Okay? I'm going to try with only method 2. Not as a sales pitch, just as a, hey, consider the possibility here. However, before I even start, this needs some help. Trying to, it's just a tap there, is it? Well, before I even start, what has to happen here, friends?
You have to do the 2.
Yeah. All this transformation stuff only works when that x is by itself. So this is the first one. You can just feel it coming. I'm going to put at least one on the test that does that. Y equals 3 cosine, big bracket, 2x plus 45. Use a big bracket in these situations so you can have both your brackets. You could also use a square bracket, but that messes people up sometimes. So for now, I'll just use a big bracket. Okay, here's what method 2 people will do. They won't worry about the phase shift or the vertical translation. That's part of the fun of method 2 later. We'll do that later. All they worry about is, give me the amplitude and give me the period. And method 2 people are like, the amplitude's right out front. You don't have to think about it. It's that number out front. It's always right there. It's the 3. That's always going to be the amplitude. And that is true. That is always true in sine and cosine. That number out front is the amplitude. The period, they're going to have to think a little bit, though. Normally, cosine is 360 to do a full loop, but this thing's been horizontally compressed by factor 2, so they'll just think like this. They'll go, oh, take that 360 and divide it by 2. My new period is 180. So yes, method 2 people need to think just a little bit about the period. Then they stop and they go, that's good enough for me. I'll take care of the rest of it later. Then they make a scale. And I'm going to use 45s here. So I'm going to go 90, 180, 270, 360, like that. Oh no, the period's only 180. I can go wider than that. And that would have worked fine. I don't want you to think what I did was wrong. That would have worked just fine. My issue with it is that you might not be able to see very well when I'm done. So I'm going to widen it out a little bit. Now, method 2 people, if you were loving method 2 before, just pay attention here. Cosine starts at the top, and I need it to end after 180 degrees. Here's how I do it. I go, okay, starts at the top, and it ends after 180. That's new. That's a new way of thinking about this, is to go, I'm just going to write to the end of cosine. Now I can already see what this whole thing's going to look like. So halfway through its cycle, it's going to be there, and halfway through there, it's going to be there, and halfway through there, it's going to be there. If that was too fast for you, I totally get it. But that is efficiency. That's what method 2 offers. A little more thinking, but a little more efficiency. There's a graph of cosine with the right period and the right amplitude, and I did it pretty quick without a table of values, with a whole lot of multiplying and confusing stuff. I just hammered it down. It's 180 wide, and it goes up to 3 and negative 3, and cosine starts at the top. Everything is good. Questions, though? It's incorrect, though. Yeah? And for you, when I write in orange, you should be writing very lightly, because you know this is not the final story. Really helpful, though. It's the right amplitude and period. It's perfect shape. It just has to be moved around. So then, method 2 people will then go, okay, but I still have to go left 45 and up 1. But here's where the fun is. Watch this. This is fun. Take each of these points and go left 45, up 1. There's left 45, up 1. This one goes left 45, up 1. This one goes left 45, up 1. Left 45, up 1. Left 45, up 1. Maybe you and I have different definitions of fun, but I sort of find that fun to just move those points like that. There's one cycle of cosine. In advanced functions, we'll finish off that first cycle. We want a cycle that starts at 0 and we'll finish it off. So then to there. And method 2 are very happy because when the question says, find the amplitude and period, like, I did that. Say, find the phase shift, like, yeah, did it. They do all those things within the question itself. They're thinking that way. Is this where I was? Yes. Phase shift right here. And so then they just have to go over here and go domain, x element of reals, range, y element of reals, such that -2 is less than or equal to y is less than or equal to 4. Now, it could be you switched teams during that example. It could be you saw that and went, I really like that now. I'm going to do that. I'm going to try that. It could be you went the other way. No, too much thinking for me. I'm going back to the tables. Yeah, that's the goal of this lesson, is to give you a method that works for you, because it doesn't matter in this course. You with me in advanced functions? I might press you towards one or the other for the things we're doing. But for now, this works great. Do you have any questions? Is there one more?
Yeah.
I think I did one that's got it all. Oh, no, not bad. It's not bad. I went back to medium, because I want you to think every question is this ridiculously hard, because it's not. There's plenty of questions that are fairly straightforward. Do you need more time here? More time? Last one. We shall vote. How many people want me to do this with method 1? Oh, how many people are method 2 people now? And how many people didn't vote at all? That's virtually everybody. Nobody cares.
I'm
Impartial, like I can do it either way, or impartial, like I haven't decided yet?
more like a Switzerland.
I refuse to state. Well, I'll do it back with method 1. I believe, even after all this time, and you might sense that I was fibbing just a little bit, I like method 2 a little better. Yeah? But for students, if you're struggling with this at all, I think method 1's the one to go with. If you're having any trouble at all. So even if you're a method 2 person and you get to a tough one, you're like, I'm having trouble with this one, then go right back to method 1. Method 1 takes a little longer, but it gets the job done. So I'll go back to method 1 here. Method 1 says, state the transformations. I have a vertical stretch times 2. I've got a left 30. And I got a down 3. I build my table of values. It's got 2 verticals and 1 horizontal, so I'm going to just move over here a little bit. And now how are we doing? Does anybody starting to make a breakthrough on the memorization of this, that they know what's coming? Where does sine start? 0. On its way up. Yeah? So then 1, 0, -1, 0. See how nice that is? You got it memorized? Now sitting there going, sine 90, sine 180, you know, or going, oh, do I put in 45s here? Or was it 60s? No, you're just like, bang, done. Then this all happens very quickly. Method 1 people are like, I don't know, Mr. Todd. I think I can beat you in a race with method. I'm good at method 1. Like, yeah, you'd be close. It's not that slow. Vertical stretch times 2, 0, 2, 0, -2, 0. Method 1 people are like, yeah, I know it's 2s. The amplitude's 2, silly. I already knew that. I'm like, okay, relax, method 2 people. It's okay. As long as we both get the right answer, we're happy. And then down 3. Down 3. -3, -1, -3, -5, -3. And finally, left 30. negative 30, 60, 150, 240, 330. And this is the only thing that I feel like I haven't said enough about, is choosing a smart scale. Because if I choose a scale of like 90 here on every square, I'm going to be in trouble a little bit when I try to move left 30. You got to think a little bit and go, what's a good choice here? And for now, I'll say usually a good choice is whatever the phase shift is, because then when you go to move at 30, that's really good. So I'm going to use a scale of 30. I'm just going to write in every third square though. 90, 180, 270, 360. And so every square is 30. And I'm well set up for this to go well. Then, going right to my final graph, because I'm on method 1, I don't have to mess around with an intermediate graph. I've got to go right through this. Negative 30, negative 3. Got to get to the bottom of why it does that crazy line. 60, negative 1. 150, negative 3. 240, negative 5. And 330, back to negative 3 again. And sometimes while you're doing it, it seems like something's out of whack, like it's not lining up right. But usually by the time you get all 5 points, you're like, oh, I see it now. And I'll put the arrows on. And I'll answer all the questions. Amplitude, 2, period, 360, phase shift, left 30, domain, x elemental reals, and range, negative 5 to negative 1. He is here.
Palmer. Good to see you right back. I see some sweatshirts though, ladies. No, just ladies.
Just ladies.
And we should be what in class?
3 of them.
In uniform. Any special plans today, Palmer?
Not really.
How do you like the new active board?
It's been a struggle. Yeah. Slow learning curve.
New technique.
It looks good. The results have been good. There's been moments of, do I use my pen? Do I use my finger? Use the mouse? We're getting it worked out though.
Okay, let me know.
Slowly but surely.
Let me know.
Sometimes by April I'll have it all figured out.
Well, happy birthday, Palmer.
Happy birthday, Palmer.